So as we continue with our transformations of linear functions, we now reach the first reflection, a reflection across the y-axis. So what are reflections? Again, we start with a parent function, which is the simplest form of the function that will generate with various transformations a large family of functions that are all similar. And in this case, it is the family of linear functions. So what is a reflection? A reflection is, again, a rigid transformation, so we're not bending. It's a transformation that flips the graph over a line of reflection, and in this case, the line of reflection, because we're talking about the y-axis, is the y-axis. So the y-axis here is in black, and what you can see is there's a reflection here of this red graph into this blue graph here. So a reflection across the y-axis really means that we're looking at the same y's, okay? So say we look at this point. We're looking at the same y, but we're saying that it has the value of the x with the opposite sign. So we're taking this point from here and transforming it to there. So if this was the point xy, now we will have the point minus xy, right? The same goes for this point here. If this point here is, we'll give the exact numbers, we have a 5 and negative 3, it will transform to negative 5, right? We change the sign of the x, but we keep the y value the same, the f of x. So it's minus 5 minus 3. So how do we get that formally without looking at the drawing? What we do is we transform f of x to f of minus x. And I've shown that here in the functions that I've written above. So we have f of x equals x plus 2. That's our red graph here. And that is our original function. And then we would like to transform it by reflecting across the y-axis. We do that by saying, oh, we have this new blue function, h of x, which is the same as f of minus x, right? This was our f of x in red. So we're taking the same f, but we're putting instead of x, minus x. So we get minus x plus 2. And I chose to use an example that has a non-zero intercept so that it's more clearly a reflection across the y-axis. So that's why I complicated it a little here. Now, again, for any function, not just for linear functions, this here is the form of a reflection across the y-axis. So again, if we make a table of x, f of x, and we'll call it h of x, which is f of negative x, right? So if we look at the point 0, our f of x here, right, is 0 plus 2, that's 2. And our h of x for x equals 0 is the same, right, because it's h of 0 equals 0 plus 2 as well, because 0 and negative 0 are the same. So again, we get 2. What about x equals 1? So f of x equals 3. We have x plus 2. But h of x now equals minus 1, negative 1 plus 2, which is just 1. And let's take one more. Let's take negative 1 here. Negative 1 is just positive 1, right? We have negative 1 plus 2, that's positive 1. But for h of x, we have f of minus x. And x is negative 1, so it's plus 1. So we have 3. So if we look at these 3 points, at x equals 0, we have both, for both we have 2 and 2. But then for x equals 1, our our red graph is at 3, right here, while our blue graph is at 1, right, which is right here. If we take -1 here, our x is at 1, that's right there, but our h of -1 is at 3, up here, right? And so we indeed get these a mirrored image of our red curve in our blue curve. So this is how we go from our red to our blue. Another way to see this is actually to look at our y's. So what happens, let's erase this and let's look at this from the other direction. Okay, so let's look at this from the direction where we have our y and x from f or x from h, right? So we can take our y, for instance, our y equals 5, this 5 here. So in our red graph, it's given by 3. So y is 5, and in our graph it's given by 3. And from our h, it's given by -3. How can we see that? Well, let's put in the values from the equation. 5 equals x plus 2. We take away 2 from both sides, and we get 3 equals x. On this side here, we have 5 equals -x plus 2. So in this case, again, we subtract 2 from both sides. We get 3 equals -x, or x equals -3. So indeed, we have these 2 points. Let's look at another example. Let's look at the example down here of, say, we can do, I guess, y equals -5. Let's look at these points here and here. Okay, so if we have -5, and I'll have to be a little bit more restrained with space here, if y equals 5, so x from f, what do? We have -5 equals x plus 2. Let's subtract 2 from both sides, and we get -7 equals x. And that is indeed what we have here, right? Let's find what our x would be from our h of x. H of x is -5, again, equals -x plus 2. Let's subtract 2. So we have -2 minus 2. So -7 equals -x, or x equals 7. And indeed, here, that's 7, right? So we got our 2 points. So this is our reflection across the y-axis, and check out the video for the reflections across the x-axis as well, so you get a full picture of what is going on. So thanks for joining me again, and continue to watch this playlist to get the full picture.